All right, this is PreCalc 1.5 homework calc. First problem says it gives us a function, and it says we're only going to use our x values that are bigger than or equal to 0. So if we take a look at this, what it looks like is it's a parabola. Usually it's a parabola that opens down, but shifted up 9 units. So we think about it like this. But we're saying, okay, let's only use the x values that are bigger than or equal to 0. And there's a reason for that, because when we find the inverse, what we're finding is the reflection over the line y equals x. So that's going to be this green function here when we're done. Something like that. Well, it's not perfect, but it probably should be shifted up a little bit or something. But anyways, the reflection over the line y equals x gives us the inverse. So to do it algebraically, what we do is we switch x and y. So I'm going to call this y f of x, and I'm going to switch it with x. So I'm going to make this x equals 9 minus y squared. Now I'm going to solve for y. So I'm going to subtract 9 from both sides. I'm going to multiply everything through by a -1, and then square root both sides. Now when I square, I have to do plus or minus, which gives me two parts. But because this x is greater than or equal to 0, I only need the positive. All right, you can graph that in your calculator. Let me actually graph this really quick for you. All right, so here's what they look like. Here's the original parabola, which we said we only wanted this right branch. So then, when you reflect this right branch over the line y equals x, the inverse is this one. Now, obviously, we would have this negative branch here as well if we entered that in, down here. But because we threw away this left piece, this bottom piece goes away as well. So we only need this answer right here. Yeah, I don't know if that recorded, so it's both. It's both because it passes the horizontal and vertical line test. So anytime that happens, we're going to call that function 1-to-1. And what it means is the inverse is also a function. The inverse in this case is the log, which we'll learn about later. But if it passes the horizontal and vertical line test both, that means it's 1-to-1. And that means the equation is a function of y in terms of x, and its inverse would be a function of x in terms of y, and they're both functions. Okay, the next question says, if this is our function, what's the inverse? Well, the inverse is what you get when you switch x and y. So if you switch x and y, you get this, and if you multiply both sides by y and divide by x, then you end up with what you started with, which is the same function. So it turns out that this hyperbola, when you reflect it over the line y equals x right here, you get the same function back, which makes sense. You can kind of see that it's symmetric. So you'd say the same thing, 1 over x. And the same thing for this one. When you have the line y equals x, which is this green line, when you reflect it over the line y equals x, you obviously get the same line back. So when you do the inverse of this one, you still get x. Okay, to find the inverse of these, we switch x and y. So we have x equals 11y plus 11. Then we solve for y. We subtract 11 and then divide by 11. So there's the answer for this one. Okay, next one, you do the same thing. You switch x and y. So you're going to have x equals 5y cubed minus 2. And then you're going to solve. So you have x plus 2 equals 5y cubed. And you're going to divide by 5. And you're going to cube root. So that's your inverse function now for g inverse. Next one, same thing. We switch x and y. So you have 11 over y plus 2 equals x, and you solve for y. So I'd cross multiply, and you get 11 equals y plus 2 times x. And then you would divide by x and subtract 2 from both sides. So you get y equals 11 over x minus 2. Goes here. And the last one, once again, you switch x and y. So it'd be x equals cube root of y plus 5, and you solve for y. So that would be cube both sides, and then you subtract 5. So y would equal x cubed minus 5 here. Or instead of y, then you can replace it back. I use y because it makes it easier than writing this, but technically it's j inverse, not y. So you do the inverse of j of x when you're done to just get rid of that y. I use y because, like I said, it's easier to write and not make a mistake when you do the algebra. Okay, let's do it again. We want an inverse function of x right here, so we're going to switch x and y. Like I said, I use y instead of f inverse, but so I have x equals 5 plus square root of 2 plus 11y, and then subtract 5. Now square both sides. That gets rid of this radical. Subtract 2. And then divide by 11. So when you divide by 11, you have to divide everything through by 11. But that is the function, and instead of y, we should call that f inverse of x. All right. Now, it wants to know the domain of the inverse. Now, this gets a little interesting. The domain of the inverse function. Now, to do that, we're going to take a look at the original function. So what we can do is we can find the domain and range of the original function and switch them, because inverse is the domain and range just switches. So that's what we should do here. So the domain of the original function is all real numbers except for, we know that 2 plus 11x has to be bigger than or equal to 0. So when we subtract 2 from both sides, we get 11x is greater than or equal to negative 2. Divide both sides by 11, we get x is greater than or equal to negative 2 over 11. That's the domain. I'm going to write that in interval notation as negative 2 over 11 bracket all the way up to positive infinity. Then the range would be 5 up to infinity. And you can have 5. And how I know that is because the largest this quantity can be right here is 0. Other than that, it's got to be positive, otherwise we get an undefined value. So 5 is the smallest this number can get, and I'm going to add to that. You can always look at the graph too in decimals, and you can see that the range is going to be 5 and bigger. It helps to know both algebraic and looking at the graph. But for inverses, what's nice about this is the inverse just switches the domain and range. That's what inverses do. So when it asks for the domain here, you just give the range. So in this case, it'd be 5 to infinity. All right, next problem wants us to find the inverse again. Once again, we switch x and y, or x and f of x. We get x equals y over 8y minus 4. All right, this one's a little tricky. I'm going to have to get y's together somehow. So let's cross multiply. We get x times 8y minus 4 equals y. I'll distribute the x, so I get 8xy minus 4x equals y. I'll get the y's together on one side, so I'll have 8xy minus y equals 4x. I just switch these two. And then I'll factor out a y. So that gives me 8x minus 1 equals 4x. And then I'll divide both sides by this quantity. So I get 4x over 8x minus 1. That is my function for my inverse. So now I'll just call that f inverse. Now, I asked some questions. It says the domain of f is x except for x can't be, well, we know x can't be 1/2. Because if we stick in 1/2, we get 0 in the bottom, and that's a problem. The domain of the inverse is all real numbers except for, well, let me look at f of x here. We just said the domain was all real numbers, so I'll say all real numbers except for x cannot be 1/2. The range for f is all real numbers except for it has a horizontal asymptote at 1/8. So y cannot be equal to 1/8. It's all real numbers except y can't be equal to 1/8. That's on our formula sheet because the exponent's 1 in the top and bottom. The horizontal asymptote is a fraction of the leading coefficients. You can graph it and see that if you want. But it is a hyperbola, and at 1/8 it has an asymptote right here, a horizontal asymptote. So that's not a value that's in the range. So when the inverse, we switch the domain and range. So this range becomes the domain. This would be 1/8. Okay. The range of the original function was everything but 1/8, and then the range of the inverse is now the domain, so that'd be 1/2. So keep in mind that our function and its inverse, the domain and range are just switched. All right, the next problem then, it says here's f, and it says and g of y is the inverse to f. So keep in mind g is the inverse. It says find the composition of g of f of x. All right, if g of y is the inverse of this, then when you do the composition, you should get x every time, both ways. So that's the key to inverses, is that they basically undo one another and give you back. If function f, adds 3 and multiplies by 5, then g better undo that if g is going to be the inverse. That's what inverses do. They're functions that basically undo one another. So it says find a formula for x equals g of y. Well, that's the inverse formula. So to find that, once again, we need to switch x and y. So this becomes x equals 8 times y plus 5/2. So what this function does is it adds 5/2 to all the x values and then multiplies by 8. Well, the inverse is going to just do the opposite. So solve for y now, and you get x over 8 equals y plus 5/2. Subtract 5/2, you get y equals x over 8 minus 5/2. So here's the inverse function, which they wanted us to call g of y. So I guess I can use y here instead. So what it does is, it takes your values, it divides by 8 and subtracts 5/2. The last one added 5/2 and multiplied by 8. It does the exact opposite. We've already talked about this, but if you're given a function, how do you find the inverse? You reflect it over the line y equals x. This next problem wants us to eliminate the parameter t. Now, we're going to get into parametric equations later in this class, where we have x defined by this third variable t, and we have y defined by this third variable t. So all the ordered pairs are kind of dependent on a third variable. To get rid of that variable, what you can do is solve one of the equations for t. So I'll do x. So that'll be t equals x minus 14, and then switch the sign. So it'll be negative x plus 14 if you solve the first one for t. Now you can plug that into y. So you have y equals negative 9 minus 4 times negative x plus 14. And just simplify it. That's distribute the negative 4 to both. You get negative 9 plus 4x plus or minus 4 times 14 is 56. So it'll be negative 56 plus negative 9, which is negative 65. To put it in standard form or slope-intercept form, which is what they wanted. So my n would be 4, my y-intercept would be negative 65. So basically, I realize this is a weird parametric equation that relies on a third variable, which we'll talk about, but really it's just a line. If we put our calculator in parametric mode, which we'll do later, and graph this, it just happens to be a line. All right, last question asks how the function is 1-to-1. So I think it's easiest to look at the graph. This is a cubic function, which we know looks like this. It passes the horizontal line test and the vertical line test, so I'd say yes. Next one is the absolute value function. It happens to be shifted over to the right 8, but it doesn't pass the horizontal line test, so its inverse is not a function, so I'd say no. Next one's the line. It's shifted up 4, has a slope of 6, so something like that. That does pass the horizontal and vertical line test, both, so its inverse is also a function. And the last one is a hyperbola, where it looks like this, and that does pass the horizontal and vertical line test, so that function is 1-to-1 as well. Hope this helps.